Hey people, today we are going to discuss LeetCode problem average of levels in binary tree. So in this problem we are given a binary tree and we are asked to find the average values at every level. Okay, so let me give you an example. In this binary tree, so there is this level 0, right? There is only one element in this level, that is 3. So the average will be 3. So in the level 1 there are two elements, okay, two nodes basically. So at this level the average will be 9 plus 20 by 2, that is 14.5. And at this level, in the level 2, there are two more elements, that is two more nodes, and the average now becomes 15 plus 7 by 2, that is 22 by 2, that is 11, right? So these are the values that we have to return in form of list. So that's the whole problem. And how I thought about this problem, like, what was my thought process. So when I read this question, I found there is one key term in this entire question, that is we have to find the average values of nodes on each level, right? So this is one big keyword. So what I do is, whenever I see something like at each level, my first idea would be to think about BFS solution. So once I understood that, okay, I have to use BFS, and I know that I have to make some minor tweaks to the original BFS solution. So that then I returned to this part where I read this, okay, the average value, so average value of the node. Okay, so average value needs two things. One is it needs sum of the values at each level, right? That's what we are doing here, right? The sum of the values here is 3 and number of nodes is 1, so the average becomes 3 by 1, that is 3. So similarly that we are doing in all the levels, right? So one, we need the sum of all the nodes in a particular level, and the second thing that we need is number of nodes in that level, right? So we need number of nodes in a given level, right? If we have these two elements, that is one sum and the number of nodes in a particular level, then finding the average at that particular level is quite straightforward, right? So these are the two things that I felt I need to keep a note of. So this was my next step. So this was my first step, and this was my second step. Okay, after finding these two things, then it became quite straightforward. So I have to tweak the BFS solution by just taking couple more variables to store these two values, and finally at every level, once I reach the end of every level, then I have to find the average and I have to store the average, I have to append the average into the result list. So this was the whole idea that I had in my mind before I started off with this solution. So this is the code, guys. Initially I'm initiating the queue with just root node and I'm taking an empty result list. Okay, so then what I'm doing is, while there is any element that is present in the queue, first I'm trying to find the size of the queue. Okay, that is like, it will give me length of the nodes that are present at given level. Like, let me show you. Okay, so initially these are the values, right? Like, we have just root node, that is 3 in the queue, and yeah, by the way, like, I'm just taking this example one for that, for convenience, and our result list is empty. Okay, so first I'm trying to find the size of this queue. So the size will be 1, right? And initially I'm taking my I to be 0 and some of the nodes to be 0. Okay, so while there are any elements left in the queue, and like, that are not traversed, so initially my I is 0 and I is less than size, right? Like, there is one more node that is not traversed, right? So that is 3. So what I'm trying to do is, so in this step I'm trying to first pop the element. Okay, so I'm just popping this out, and then I'm adding the value to the sum of the nodes variable, right? So what I'm trying to do is my sum of the nodes will be updated with the value 3. Okay, once this is done, I'm checking if my current node has any left or right children. So in this case we have two children, right? 9 and 20 nodes, so we are adding them to the queue. So that's what we are doing in the 19th and 21st line. So that is, we are adding 9 and then we are adding 20. So once that is done, we are incrementing the I, right? So my I now becomes 1. So and like again it will come to this while condition, and since our I is not less than size, so as I is equals to 1 and size is equals to also 1, so this will exit this while loop, and now my result, like I'm appending the sum of nodes divided by size to my result, like as size is the number of nodes at any at a current level in the tree, binary tree, right? And this is what we need, like the sum of nodes is what we need to calculate the average, right? So that's what we are doing. We are dividing the sum of nodes with size, that is 3 divided by 1. So we are appending this 3 value to the result list, right? Once this is done, we are repeating the same process. So for the next step, what it happens is we have 9 and 20, and now size becomes 2. Once this is 2, and we are initializing our I to be 0 again and sum of nodes to be 0 again, right? Here we are doing that. And now what we are trying to do is, while our I is less than size, we are trying to pop the first element from queue. So we don't have this 9 here anymore, and we are adding the uh, popped elements value to the sum of nodes. So now we are adding the value to sum of nodes, so our sum of nodes will become 9 again, and we are incrementing the I with 1, and we are checking if 9, the node 9 has any left or right children. So since we don't have any children for the node 9, we are just going to the next step, that is since our I is still less than size, we are popping the element again. Now we are adding this value to the sum nodes. Now our sum nodes will become 29, right? So then what we are trying to do is, we are checking if our current node, that is 20, has any left or right children. We have two children, 15 and 7, so we are adding these values to the queue, right? Since we have done these two things, now we have to increment our I. Now our I is again 2, and since our I is equals to size, we are exiting the while loop, since this condition doesn't satisfy anymore, and now we are trying to append the value that is equals to sum of nodes divided by size. So that is 29 divided by 2, so we are now appending the 14.5 value in our result, right? And this process continues as long as we have any elements left in the queue. So once this whole process is done, we'll just have our final result list, and we are just returning this result list. So that's the code and logic of this solution, guys. So if you really like this video, please like, comment and subscribe to my channel. And if you find this useful, please share it with your friends as well. That will keep me motivated to do more videos. So thank you so much.